How are you everybody? How are you today? This is the third lecture related to advanced mathematics. This is the course of a fourth year statistic English section at Banha University 2020. This is the third lecture and the important lecture related also to the series and sequence. Geometric sequence. What is the meaning of geometric sequence? In the previous lecture we stated and explained an arithmetic sequence and arithmetic series, but now we will discuss geometric sequence. What is the geometric sequence? What do geometric sequence apply to a bouncing ball? Geometric sequence, the height of the first rebound of the ball. Geometric sequence is a sequence in which each term after the first term is found by multiplying the previous term by a constant r and called the common ratio. This is the definition, the direct definition of geometric sequence. A geometric sequence is a sequence in which each term after the first is founded by multiplying the previous term by a constant r. These are called the common ratio. As with an arithmetic sequence, you can label the terms of geometric sequence as A1, A2, A3 and so on. The nth term is A sub n and the previous term is A sub n minus 1. This is also, there is no any problem. The term an and the previous term A sub n minus 1. This is no problem. So an equal r multiplied by A sub n minus 1. Thus r equal an over A sub n minus 1. It is very important to know these symbols. A sub n equal r multiplied by A sub n minus 1. Thus r equal A sub n over A sub n minus 1. That is, the common ratio can be found by dividing any term by its previous term. The common ratio can be found by dividing any term by its previous term. It's very important. It is very important. This line is very important about the geometric sequence. A geometric sequence is a sequence in which each term after the first term is found by multiplying the previous term by a constant r, called the common ratio. As with an arithmetic sequence, you can label the terms of a geometric sequence as A1, A2, A3 and so on. Thus the nth term is A sub n and the previous term is A sub n minus 1. So A sub n equal r multiplied by A sub n minus 1. Thus r equal A sub n over A sub n minus 1. That is, the common ratio can be found by dividing any term by its previous term. It's very obviously very clear and very easy to understand. What is the meaning of geometric sequence? What is R, a common ratio in geometric sequence? What is the nth term in the geometric sequence? Example number 1. Find the next term, multiple choice of term. Find the missing term in this geometric 8, 20, 50, 125. It's obviously the term, the last term, can be found by dividing by the first term. Read the test I. Since 20 over 80 equal 25, 50 over 20 equal 25, 125 over 50 equal 25. The sequence has a common ratio 25. Solve the test I. To find the missing term, multiply 125 by 25, 3125. The answer is D. It's very important because the final exam will be a multiple choice. This is a multiple choice test item. You must understand very closely the type of MCQ multiple choice question which are related to advanced mathematics course. It's very important. You have seen that each term of a geometric sequence can be expressed in terms of R and its previous term. It's also possible to develop a formula that expresses each term of a geometric sequence in the form of R and the first term A sub 1. Study the pattern shown in the table on the next page for the sequence 2, 6, 18 and 54. It's very important. This slide is very important to understanding very closely. I want from every student to understand this very closely. How we can find the missing term in a geometric sequence. How we can find a missing term in a geometric sequence. This table related to a geometric sequence 2, 6, 18, 54, A1, A2, A3, A4 up to sub AN. Expressed in terms of R. 2 multiplied by 3, 6 multiplied by 3, 18 multiplied by 3 equals 54. Symbols A1 multiplied by R, A2 multiplied by R, A3 multiplied by R. Numbers 2 multiplied by 3, 2 multiplied by 9, 2 multiplied by 27. Number 2 multiplied 3 to the power 0, 2 multiplied 3 to the power 1, expressed in R term, 2 multiplied 3 to the power 2, 2 multiplied 3 to the power 3, A sub n R sub 0, A sub n R to the power 1, A sub 1 multiplied by R to the power 2, A sub 1 multiplied by R to the power 3, A sub 1 multiplied by R to the power n minus 1. Oh, this is very important. The three entries in the last column, A sub n minus 1 multiplied by R, A sub 1 multiplied by R to the power n minus 1. The three entries in the last column of the table all describe the nth term of a geometric sequence. This leads us to the following formula for finding the nth term of geometric sequence. This is a mathematical induction. This is a mathematical induction about the nth term of a geometric sequence. It's very important to know how we can make a mathematical induction about the geometric sequence. Nth term, the nth term A sub n of a geometric sequence with the first term A sub 1 and the common ratio R is given by A sub n multiplied by A1 multiplied by R to the power n minus 1, where n is any positive integer. A can take 0, 1, 2, 3, 4, 5 up to n small. So that this is the key concept, the nth term of geometric sequence, how we can make a mathematical induction, how we can make a proof about a nth term of geometric sequence as shown in the table in this first. This is an example. Find a particular term. Find the eighth term of geometric sequence for which A1 equal minus 3 and the common ratio R equal minus 2. It is direct application, direct substitution. There is no problem. I want from every student to solve example number 2. It's obviously solved, but you must study very closely. Example number 3, write an equation for the nth term. You can also use the formula for the nth term if you know the common ratio R and one term A of a geometric sequence, but not the first term. So that it's very important to understand example number 2, example number 3, and it's a direct application, direct substitution in the geometric sequence K concept and geometric sequence common ratio R. There is no any problem, but you must solve and check these answers to make your understand very closely to geometric sequence. Another example related also to the geometric sequence. Example number 4. Find a term given the fourth term and ratio. Fourth term A sub 4 and the common ratio R equal 3. No problem. Find the length term of a geometric sequence for which A4 equal 108 and R equal 3. First find the value of A1. There is no any problem. Direct substitution. direct substitution in the mathematical form of geometric sequence. You must check this answer and understand very closely the direct application for a geometric sequence, and you must study very closely to know the different example, different application about the geometric sequence. Now, how we can obtain a mean of a geometric? Geometric means you learned that missing term between two non-successive terms in an arithmetic sequence are called arithmetic means. Similarly, the missing terms between two non-successive terms of a geometric sequence are called geometric mean. For example, 6, 18, and 54 are three geometric means between 2 and 162 in the sequence 2, 6, 18, 54, 162. You can use the common ratio to find the geometric mean. You can use the common ratio to find the geometric means in a given sequence. Find geometric mean. Find three geometric mean between 2.25 and 176. You can use the nth term to find the value of r in the sequence, so that you can find r equal plus or minus 4, and you can also write a2, a3, a4, and so on by r plus and r minus 4. This is another application for geometric means, and every student must study this solution very closely and understand very closely to understand the main idea about geometric mean. Check for understanding. Number 1, decide whether each sequence is arithmetic or geometric. Explain. Open-ended right geometric sequence, the common ratio of 2/3. Find the error. Okay? Guide practice. Find the next two terms of each geometric sequence. Find the first 5 terms of geometric sequence for which a1 equal minus 2 and r equals 3. It's also very direct and easy example related to geometric sequence. I want from every student to check all these answers and solve it for make more and very closely understanding for the geometric sequence mean, as geometric sequence ratio, as geometric sequence, geometric series idea very closely. Also, exercises and more practice about the geometric sequence. 7, 8, 10, 11, 12, 9, 10, 11, 12. Practice and apply. I want from every student to solve this exercise, this practice, to check the understanding about the geometric sequence, the geometric series, the mean of geometric sequence and geometric series, the common ratio r, and the nth term of a geometric sequence and geometric series. I want from every student to solve and understand very closely to make a check for your understanding for this important topic in our course Advanced Mathematics. Maintain your skills. Mixed review, also a direct practice, a direct application, a direct exercises about the geometric sequence, geometric series, the meaning of geometric sequence, the meaning of geometric series, the nth term of geometric sequence, and the practice quiz 1. I want from your student also to check the understanding about this very important topic in our advanced mathematics course, and make more and more solution to this practice, to these exercises, to check, to understand this very important topic very closely. Thank you for everybody, and see you in the next lecture. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.